In this class, we're going to go over questions on implicit function. What exactly do we mean by implicit function? A function that is not expressed directly is what we call implicit function. Are you paying attention? When we talk about implicit function, the function is expressed indirectly. Are you there? So let's say we are given a function like this: y plus x squared equals to 0. This is a typical example of implicit function. But to differentiate this function, you can easily make y the subject of the relation. Okay, let's say you are asked to find the y over the x as touching this function. Are you paying attention? Now, you can easily make y the subject of the relation and then differentiate this function. But what of if you have something like this: y squared plus xy equals to 0. Both functions are implicit functions, but the first question can easily be differentiated by making y the subject of the relation. Okay, so here let's make y the subject of the relation in the first question. Solution: we are going to have y plus x squared equals to 0. So y equals to negative x squared. You can easily differentiate this using the power rule. You understand? So I'm going to have the derivative of y equals to 2 multiplied by negative x raised to the power of 2 minus 1. You understand? Don't forget that we've learned many rules of differentiation in our previous class, such as the first principle, the power rule or the polynomial rule, the chain rule, the quotient rule, the logarithmic differentiation. All these rules are very important as far as differential calculus is concerned. Are you paying attention? Because you might be given a question where you are going to combine more than two rules to differentiate the function. Okay, so peradventure, if you miss those classes, you can easily check this channel and watch the video, and you can as well join our membership program. Okay, now with respect to this, we are going to have something like this: y derivative of y equals to negative 2x raised to the power of 1. You understand? Okay, so the derivative of y equals to negative 2x. That is the final answer. Okay, now let us proceed to the second question. We have y squared plus xy equals to 0. Please kindly pay attention. Okay, in differentiating this function, we are going to differentiate with respect to x. Okay, if you come across any question on implicit function, okay, you are going to be asked to differentiate with respect to a variable. You understand? Now, in this question, we are differentiating with respect to x. In that case, I'm going to differentiate y with respect to x. Hence, my differential equation will be in this form: dy dx equals to this. Okay? Now, you know that I'm differentiating with respect to x. How many variables do we have in this equation? We're having two. One is y and the other is x. So, anytime you differentiate y, you are going to add dy dx. Okay? Look at this. We have y squared plus xy equals to 0. Whenever you differentiate y, you are going to add dy dx. Okay? Now, let us differentiate y squared. You have to differentiate each term individually. Okay? Let us first differentiate y squared. Here, I'm going to have dy squared all over dy. Don't forget, I told you, anytime you differentiate y, you are going to add dy dx. You understand? You are going to multiply the derivative by dy dx. So I'm going to have multiply by dy all over dx plus. Now we have xy. What is the sign between xy? The sign between xy is a product sign. Here, I'm going to differentiate xy using the product rule. You can see now. So, it is very important that you understand all these rules. Are you there? It is very important that you understand all these rules. The product rule, we are going to use it to differentiate xy. So, if you want to use the product rule to differentiate xy, we are going to differentiate it one by one. According to product rule, you are going to keep one part constant. You see, this function xy has two parts. The first part is x and the second part is y. You understand? Now, in an attempt to differentiate this function, you have to keep one part constant and differentiate the other, then keep the other part constant and differentiate the first part. You understand? According to product, you are going to have derivative of x multiplied by y plus derivative of y multiplied by x. You understand? Okay, and I told you anytime you are differentiating y, you're going to add the y dx. Okay, so if you differentiate x, that will be 1. So I'm going to have 1 multiplied by y. Are you there? 1 multiplied by y plus derivative of y multiplied by x. So here I'm going to have y plus dy all over dx multiplied by x. I'm going to explain, just pay attention. See, according to chain rule, if you are told to differentiate a function that has two parts, and these two parts are multiplying each other, such as x and y, the chain rule states that you are going to differentiate, keep one part, keep it constant. The first part here is u, so keep u constant, differentiate v, then add it to the differentiate u now, and then keep v constant. That is the formula for chain rule. So if you missed the previous class on chain rule, you can check the channel and watch those videos. Okay, now let us differentiate xy. Here I'm going to have, okay, let's keep x constant. Keep x constant. Keep x constant. Differentiate y plus, now keep y constant, then differentiate x. I'm going to have dx all over dx. Okay, see, this implicit differentiation is simple. I told you anytime you are differentiating y, you had those are the basic things that you need as far as understanding implicit, how to find the derivative of an implicit function is concerned. Okay, when I get here, I keep x constant according to product rule, then I differentiate y, and I know that, see, if I differentiate, I have xy, keep x constant, differentiate y, dy, I'm going to have dy over dx, multiply dy over dx, then plus keep y constant and differentiate x, dx over dx, because we are differentiating with respect to x. Okay, now look, dy will differentiate y will give me 1. So 1 times dy dx is what? X dy over dx. That's how I arrive here. Plus y, dx over dx is 1. 1 times 1 is y. So that's why I have y. You can see that it's simple. Okay, see, you have to understand this. This is just the basic concept as far as implicit function is concerned. Okay, now let's proceed to with the solution to the question. Don't worry, if you didn't understand this one, you are going to understand by the time we solve 2, 3, 4 questions on this particular concept, implicit function. Okay, now here I'm going to have 2y differentiate y squared, that is 2y, multiplied by dy over dx is equals to x multiplied by dy dx plus y multiplied by 1. You understand? So I'm going to have 2y multiplied by dy all over dx is equals to x multiplied by dy over dx plus y. Okay, now do you know that what I'm looking for is the derivative of y with respect to x? You understand? We are asked to differentiate this function with respect to x. So here I'm going to have 2y multiplied by dy all over dx minus x multiplied by dy all over dx equals to y. Do you know what I did? I just take this x dy dx to the other side because I want to factorize dy dx. Okay? Now, if you are to factorize dy dx, because dy dx is common to both 2y and x, so I'm going to have dy all over dx into brackets 2y minus x. If you open this bracket using dy dx, you are still going to have 2y dy minus x dy dx. Okay, 2y dy dx minus x dy dx, okay, equals to y. This equals to y, okay. Now, to get dy dx, all you have to do is that just divide both sides by what? 2y minus x. So, this side all over 2y minus x, and this side all over 2y minus x. So therefore, I'm going to have dy all over dx is equals to y all over 2y minus x, okay? So that is the derivative of that implicit function that we are asked to differentiate, okay? If you have any question, let me know in the comment section. Now, let's solve one more example. Find the derivative of x squared y minus 6x equals to 3. Find the derivative of x squared y minus 6x equals to 3. This is a typical example of an implicit function, you understand? And the reason is because this function is indirectly expressed, you understand? The function is expressed indirectly. You know, when we are dealing with other methods, like chain rule, those questions there are not those functions that we are differentiating back then, they are not implicit, you understand, because they are directly expressed. Example is, if I have something like y equals to 2x plus 4x squared. This is a typical example of a function that is directly expressed because we have a variable is equals to another. It is expressed directly, you understand? Now, but this kind of function, it is not expressed indirectly. So in an attempt to help us to differentiate such function, we make use of implicit differentiation, you understand? We differentiate the function implicitly. And the basic rules is that anytime you are differentiating a function using the anytime you are differentiating an implicit function, you are going to add, for example, look at this function now. We are differentiating with respect to x. And the variable that you're having in this function is what? Is y and x. So anytime I differentiate y, I'm going to add dy dx. That is the basic rule, okay? Now, let's find the derivative of x squared y minus 6x. To help us to find the derivative of x squared y minus 6x, what is the sign between x squared and y? The sign is product. So, in an attempt to help me to differentiate x squared y, I'm going to employ the product rule. See, you know, when we are dealing, when we differentiated xy here, maybe you didn't understand. Now, pay attention again. Here is another example with that's related to this. Okay. Now, according to product rule, if we have a function that has two parts, and these two parts are multiplying each other, to differentiate such function using the product rule, you have to keep the first part, keep it constant, or keep one part constant, differentiate the other, add the additional sign, then keep the other part constant, differentiate the other. You understand? That is the basic rule. All this one you didn't have to cram. Okay. Now we have x squared 1 minus 6x. Let us first differentiate x squared y. Now x squared is the first part, and y is the second part. Let us keep. Okay, let's look what I did here. Okay, let us keep x squared constant, then differentiate y. Then we're going to keep y constant and differentiate x squared. You understand? Okay, let's proceed. Let us keep x squared constant. I'm going to have x squared. Now let us differentiate y. dy all over dx. The reason why we have this is because we are differentiating with respect to x. You understand? Now, because we are using the product rule, we are going to have an additional sign plus. Now, we are going to keep y constant. So I'm going to have plus y multiplied by dx squared all over dx. Don't forget, the reason why I'm having the x as the denominator of the differential is because I'm differentiating with respect to x, okay? So I differentiate x squared, I differentiate y, which is this, with respect to x, and I differentiate x squared as well with respect to x. You understand? So I'm left with what? I keep x squared constant here, differentiate y, plus I keep y constant now, I differentiate x squared. Do you understand? Okay, minus, okay, now let us differentiate 6x. All you have to do is just put the 6x all over the x, equals to, if you differentiate a constant, you're going to have 0, and you can put it. Yes, if you differentiate a constant, you're going to have a 0. So just put 0, okay? Now, let us proceed. We're going to have x squared dy over dx plus y multiplied by, if you differentiate x squared, you're going to have 2x, y multiplied by 2x. Are you there? Y multiplied by 2x minus, if you differentiate 6x, you're going to have 6 minus 6 equals to 0. Okay? Please kindly pay attention. Here I'm going to have x squared dy all over dx is equals to 2xy minus 6 equals to 0. Now, the goals of the question is to determine dy dx, you understand? Is to determine the derivative of y with respect to x. So, I'm going to make dy dx the subject of the relation. I'm going to have dy x squared dy over dx is equals to, oh sorry, this is additional sign, okay, sorry, okay. Now take this negative 6 to the other side. I'm going to have 6, this positive 2xy, I'm going to have negative 2xy, okay. Now the next step is that we are going to divide both sides by x squared, by x squared. So I'm going to have this over x squared, this over x squared. Hence dy all over dx is equals to 6 minus 2xy all over x squared. You can see that to differentiate a function and to differentiate an implicit function is quite simple. What matters is understanding, you understand? Understanding the subject matter, and I've already explained. If you are asked to differentiate a function with respect to another function, if you are asked to differentiate an implicit function with respect to another function, for example, we are differentiating y with respect to x. That means that anytime I differentiate y in the function, I'm going to add dy dx, okay? Are you there? So that is why, let's say you are asked to differentiate a function that contains z and x, and you are differentiating z with respect to x. That means that anytime you differentiate z in that function, you're going to add dz dx, you understand? Now, you might want to ask me this question, that why don't I add dy dx when I differentiate this y? You see, when I differentiate dy, when I differentiate dy, y doesn't have any power, you understand? So it already gave me dy dx. That's why I didn't add dy dx, you understand what I'm saying? That's why I didn't multiply it by dy dx, you understand what I'm saying? So, and if you differentiate y, you're going to have 1 times dy dx will give us dy dx. This is what I'm trying to say. You might be wondering that why don't I add dy dx to, why don't I multiply this by dy dx? If you differentiate y, you're going to have 1, you understand? So 1 times dy dx, that will be what? Dy dx. I'm very sure you understood. If you didn't understand, let me know in the comment section, okay? And if you have any question with respect to what we learned in this class, let me know in the comment section as well, okay? So the derivative of this is this. Why the derivative of this will give us this. And you see, the first question is easy to differentiate because you can easily express it directly, you understand? You can easily express it as a direct function, but in this case, you have to differentiate it implicitly, okay? So that is the solution to both questions, okay? You might consider joining our membership program. That is from grade 7 to grade 12. I'm very sure some of you are doing further mathematics, and it's just a token